Section 2.2 Interactive Assignment Objective 4. The data below represent the per capita average disposable income after taxes for 25 randomly selected cities in a recent year. We're going to complete parts A and B. For part A, we want to be able to construct a frequency histogram of the data with a first class having a lower class limit of 30,000 and a class width of 6,000. So, a histogram is constructed by drawing rectangles for each class of data. For a frequency histogram, the height of each rectangle is the frequency of the class. The width of each rectangle is the same, and the rectangles touch each other. As stated, we're going to use 30,000 as the lower limit of the first class and a class width of 6,000. So, let's go ahead and do that. So we know that our lower class limit is 30,000 for the first class. If we add 6,000 to that, that gives us 36,000. If we add 6,000 to that, that gives us 42,000. And if we add 6,000 to that, that gives us 48,000. Okay, now the upper class limit, we could take the lower class limit for the second class, which is 36,000, and subtract 1, and that gives us 35,999. So therefore, that represents the upper class limit for the first class. And then we can just add 6,000 to each value. So let's go ahead and do that. If we take 35,999, add 6,000, that gives us 41,999 for the upper class limit of the second class. Okay, then we're going to add another 6,000, and that's going to give us 47,999. That is the upper limit for the third class. And then if we add another 6,000, we get 53,999, which is the upper class for the fourth class. Now what we want to do is we want to find the frequency of each class by looking at the data. So we want to find out what are all the values in the data that fall within the first class between 30,000 and 35,999. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 values that fall within the first class. Okay, then we're going to look at the second class, which is 36,000 to 41,999. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11. So there's 11 values that fall within that second class. The third class are the values between 42,000 and 47,999, and we do not have any values there for that, so therefore that is 0. And then in the last one, we have the number, the last class was 48,000 to 53,999, and we have one value there that falls within that class, so therefore we have 1. Now again, as remember, the histogram is constructed by drawing rectangles for each class of data. And it says, notice that the lower class limit is 30,000. So we're going to go from 30,000, and it's going to go all the way up to 13. And then it's going to go right up to 35,999. Okay, the next frequency in class is 11. So that means from 36,000 to 41,999, again, these rectangles touch, is going to be at 11. Okay, now if you notice down here, I'm going to draw a line here so that represents that first class, and that is the second class. Now, if we take a look at the third class, we have 42,000 to 47,999, but we have 0. So we're going to put a line at the bottom here to represent and I'll just make sure that there's no gap there, but that means that there's 0 in that class. And then the next one is between 48,000 and 53,999, and it's 1. So that means we're going to go up, and then therefore there is our rectangle for that class. So we can go ahead and fill it in. So we know that here is the rectangle for the first class. Here is the rectangle for the second class. And then there is the last one there. So this should represent the histogram. So let's take a look at our choices here. So is it this one here? Well, this goes all the way up to 13. This looks like it's 11. This is 0, and this is 1. Okay, this one is not. And then this one looks like it goes up to 13. It goes up to 11. It goes up to 1. But what's the difference between this one and this one? Well, if you notice here, this goes from 30 to 36. This goes from 30 to 35. We don't want this to 35 because what do we know about it goes from 30,000 to 35,999. So therefore, we can't choose this one because that horizontal axis is incorrect. So it's going to be A. So let's go ahead and choose A to make sure that we have the right one. There we go. Okay. Now what we're going to do is construct a relative frequency histogram of the data with a first class having a lower class limit of 30,000 and a class width of 6,000. Okay. So basically the classes are going to stay the same. So we know it's going to go from 30,000 to 35,999, and then we have 36,000, and I believe that's 41,999, and then 42,000 to 47,999, and then 48,000 to 53,999. Okay, now the relative frequency is taking the frequency and dividing it by the sum of the frequencies. Well, if you notice, when we add up the total here, we get a total of 25, which is given in the problem, 25. So we're going to take 13 and then divide that by 25. We're going to take 11 and then divide that by 25. We're going to take 0, divide that by 25. And we're going to take 1 and divide that by 25. And that's going to give us our relative frequency. So 13 divided by 25 gives us 0.52 or 0.52. Okay, 11 divided by 25 gives us 0.44. Okay, 0 divided by 25 is going to give us 0. And then 1 divided by 25 is going to give us 0.04. Okay, so now what we're going to do is we're going to do the same thing. We're going to create our rectangles. So for the first class going from 30,000 to 36,000, we want to go all the way up to 0.52. So all the way up to 0.5 and a little bit above there, and that's going to be 0.52. Okay, and that is the first class. The second class goes up to 0.44. So it's going to go up to 0.44. So it's going to be like right around there and coming down here. And then our next class has 0, so we have a line there. And then our next value is 0.04. So we're going to go up here and then there. So now we want to find out what is the relative frequency that we have in our problem. Okay, so it looks like this first one is not, we can't use that because you can see here that the first class is very low and that's not what we have for our relative histogram. If you see here, these rectangles are the same. So now we need to look at the horizontal axis. Well, this goes from 30 to 35, and we don't want that. We want it from 30 to 36. So therefore, this is going to be our answer, and that is our result.